apart from two, no one is joining the class on the time. Okay, so let's take what is basically the uniform
And
circular
sir,
motion. Yes.
if there's some background noise, I'm very sorry for it, but like I'm outside.
Don't worry, Preshita. I know I can understand. Alvina, like Preshita, I can understand. It sometimes happens. Don't worry about it. I can
Yes,
manage
sir.
it. Don't worry about it. So let's understand what is uniform circular motion. So whenever, let me take one thing is here. This is a circle. So this is a circle. So have you like in the childhood, like you are in childhood as well, but whenever like do you have you seen that wheel? I just
Merry-go-round.
not merry-go-round. Have you seen the big giant wheel?
Giant
The
wheel,
giant
yeah.
wheel.
Giant wheel is that, and merry-go-round is the second example. And have you world you have you tied a stone on a thread and just use this
Yeah, tangent.
it's a kind of that. So basically, uniform circular motion is an object is in circular motion. Basically, the path is circular. Clear?
Yes, sir.
Any
Yes,
doubt
sir.
in this? One more thing is
No,
that I
sir.
have how many of you have the Chan book? Hard copy or soft copy? Does anybody have Chand, Lakshmi Singh and Manjeet Kaur?
Sorry, sir.
Oh, not now, sir. I have the soft copy, but I can't find it now.
Okay, don't worry. I have downloaded the soft copy. I will share with you as well. Okay, Lakshmi Singh and Manjeet Kaur is a reference book, which is a very good book.
Yes, sir.
This book has number of numericals and concept in a very better manner way. Okay.
Okay.
That's why I'm just asking. I'm not saying that you should follow this. I'm just saying it's a suggestion. It's up to you. Clear?
Okay.
So let's take
Okay,
this
sir.
thing. Now, first thing. Now tell me, whenever the object changes its velocity, it is in accelerating motion or not? Yes or no? Whenever there is a change
Yes,
in
sir.
velocity, is there any acceleration?
Velocity or direction?
Yes. So I
Yeah,
just
so there is an acceleration in circular
Yes,
motion.
sir.
very good. Okay. Yes, Alvina?
Yes, sir. That
Very
is
good.
acceptable.
Okay. So whenever, so let me tell you the first thing is that when an object is changing its velocity, so it's basically depends on two things. Velocity has two factors. Velocity is a vector quantity, I've told you.
Yeah.
Yes, sir.
Yes or no?
Yes.
Changing
Yes, sir.
its velocity, that means that it is
It's measure
accelerating.
and it's yeah,
Very good.
the change of direction.
Okay. So the change in velocity could be due to two factors. Because velocity is if the speed has only one factor, which is magnitude. Yes or no?
Yeah.
Yes.
Speed has only one factor, which is magnitude. That's why we call this quantity as a scalar. But in velocity is a vector quantity, it has two factors. If any of the thing changes, which means that it is changing its velocity.
Velocity.
Very good. Just let me aside this thing. Clear? Accelerating.
Yes,
This
sir.
change in velocity
Magnitude
could
or
be,
direction.
yes, could be due to change in
Direction.
either magnitude or direction. So whenever a person is saying that, so somebody asks, suppose your teacher asks that question in a viva, that an object is in circular motion, does it change, that object is changing its velocity or not? So what you will say?
It's in it has acceleration.
It has
Because
acceleration.
of the change of direction
Yes. So
in the uniform
now,
speed.
now let me take this example in the middle and tell you what is basically happening when you say that object is in circular motion. So now you can see that, just a second. Let me scroll this. Now see, see that object, suppose this is the, you can say, it kind of thread and stone example. Let me take this example here. Okay. And this is the, okay. Clear? Any doubt in this?
No, sir.
Okay. So now you are standing here. Okay. And you are circulating, basically revolving it. So now stone at this point here is this point, and your motion is in this direction. In this direction. Okay. So now tell me, in this direction, this is the direction in which the stone is referring its. Just a second, let me take the arrow one. Yeah. So now if the stone is in, is like at this point, stone is saying that it's in the direction of this. Stone is in east. Yes or no?
Yes, sir.
Because it's going in this direction, na? And
Yeah.
suppose at this point, suppose the stone is at this point, suppose the another point is this, and stone is going in this direction. Yes or no? Because it's completing its circle. Yes
Yeah.
or no? It's going in south direction now. Now suppose
So the
stone has
directions
moved
are
a little bit.
constant.
Again, it has moved a little bit, but now the direction is pointing it's in the west direction. And after this point, suppose the stone is present at this point. So now you can see that it's now pointing out the north direction. Now you can see at every point, stone is referring each different direction. So Alvina and Preshita, I want answers, I want responses. Is that clear to both of you? Yes or no? You are standing here. Suppose student is there.
Yes, sir.
This is your thread. This is your stone. This is your stone. This is your stone. Okay. Is that clear to you? So whenever the object is in circular motion, the direction is tangential. Whenever you basically draw a line on the basically which is touching one point on the circle, it's called tangent. This is a tangent. Clear? So direction of uniform circular motion is tangential. Because tangent is giving out the direction in every case. Yes or no?
Yeah.
Like I think in 9th class, in circle chapter, tangent are also there.
Sir, in gravitation also we have tangent.
Yes. Is that clear?
Yes, sir.
Yes, sir.
So the direction of uniform circular motion will be given by a tangent on this circle, basically, which is the path which is representing. Yes, like Alvina and Preshita dear, let me know. Is that clear to you? Yes or no?
Yes, sir.
So you can see that if you have to basically find, suppose the stone is at this point, clear? And the direction of motion is this. Yes or no? I've told you in this direction. It's so if you draw a tangent, so this will be the direction. Yes or no? So basically this stone is pointing in this direction. Yes or no? Yes or no? Why is everybody silent? What happened?
No, sir, nothing.
Alvina and
It's
Preshita,
clear.
it's clear?
Yes.
So in uniform circular motion, it's called uniform because in this motion, basically, in this at this point of time, you are dealing with the uniform circular motion, which means that the magnitude of the velocity will not be changing, but the direction of the velocity will be changing. Clear? Why is it like, is that clear? In uniform, let me write down this thing. In uniform,
Yes, sir.
Alvina, are you there?
Yes, sir.
In uniform circular motion, magnitude of velocity will be remains constant, but the direction of the velocity will change. So now, according to the definition, according to the concept of acceleration, either the magnitude should change or the direction. So in this case, magnitude is constant, but the direction is
Direction is changing.
not constant, which is continuously changing. At every point, it's changing. But the direction of velocity will change.
Yeah.
Clear? That's why it is an accelerating motion. I will take one example of Preshita question paper. I will show you that question the Preshita have done wrong in the exam. Uniform circular motion, because basically that's it's because we haven't done that thing in the class. I know that she has done up to the mark by herself, but still, don't worry about it.
Yes, sir.
Okay, so uniform circular motion is an accelerating motion. Clear? Any doubt?
Yes, sir. No, sir.
Alvina, why are you silent, dear Alvina?
No, sir.
Is everything fine?
Yeah, it's fine, sir.
Okay, okay. Is that clear?
Clear.
Sure. Are you both of you taking notes?
Yes, sir.
Very good. So have you got this? Why it is an accelerating motion? Even the velocity is constant?
Yes, sir.
Because the either direction should change or magnitude, but magnitude is fixed, so direction is changing, which is tangential to the circle.
Yeah.
Clear?
Yes, sir.
Yes, sir.
Very good. So just give me a second. Let me take one example, like thread one example of a very like good labeled diagram so that I can show it to you. Because mine drawing is a little bit rough, so that's why I don't want, because the conceptual part I've done, so that's why I'm pasting another picture from the book so that you can understand in a better manner. So this is the example of stone and thread. Now you can see that, just a second, is that visible to everybody?
Yes, sir.
Visible. Very good.
Yeah.
Now you can see that in this stone and a thread example, now you can see that this is the stone here. The stone is here. And it's in this direction. The arrow is showing in this direction, yes or no? So at this point,
Yes,
if you
sir.
make a tangent, it will be like this way, yes or no?
Yes, sir.
Another, you will make a tangent at this point, it will be in this direction, yes or no?
Yeah.
So that's why it is called as accelerating motion, because it's continuously changing its direction. Is that clear?
Yeah.
Yes, sir.
If you're saying uniform, which means that speed will remain constant.
Yeah.
But if you say non-uniform, your direction and magnitude will both change. But at this point of time, you are only dealing with the uniform motion. So in your exams, only the uniform part will be there.
Okay, sir.
Clear? Let me write down the definition of circular motion. When an object is, or you can say when a body is moving in a circular path, with uniform speed it's called as uniform circular motion. Clear?
Yes, sir.
Yes, sir.
Clear? Any doubt in this?
No, sir.
Okay. One more thing is that basically, if you want a uniform circular motion, a force is required to perform a uniform circular motion. Okay. So now suppose that if you are if you have a thread and stone, if you need to make in a circle path, what you will do? You will just apply this in this direction or in this direction. Yes or no? Apply the force with your hand. Yes or no?
Yes,
Will
sir.
it go? Will it go without
Yes,
any
sir.
force? Will it perform uniform circular motion without any force?
No, sir.
No,
It
sir.
cannot.
Okay. So basically, examples of uniform circular motions are: have you seen satellites? They are continuously moving without any, you can say, without changing their speed. Once they go in orbit, they continuously move with a constant speed. Yes or no? Artificial satellites through which we communicate.
Yes,
So examples, let's take some examples of uniform circular motion. Clear? First part is,
Yes.
you can have some, maybe there would be like in your exam, maybe they can ask like what are the examples of this? Artificial satellites. So do you have in the final term, do you have the combined syllabus or just the second term syllabus?
So combined syllabus.
Combined
Everything
syllabus.
from the book.
Everything. Yes, yes, yes. Clear. Yes, Alvina, what do you have combined as well?
yes, sir. In the final exam, everything is coming.
Will combine. Okay, 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 dear. Moves in uniform circular motion. Now, if okay, so this is the example. Let me take one example as well. So you can see that Earth also revolve around the sun. It's a kind of uniform circular motion
Yes,
because
sir.
Earth has a fixed speed. Yes or no? Or moon has moon moves in a uniform circular motion around the Earth.
Yes, sir.
Yes or no?
Yeah.
Very good. So let me take last example. Let me take another example. The moon moves in an uniform circular motion around Earth. Okay, another example. So now tell me, now you think that I've told you that a force is required to perform uniform circular motion? Yes or no?
Yes, sir.
Okay. So basically that force is called as centripetal force. which is required to basically required by the object to move in a circular path.
Yes, sir.
It's called centripetal force. I'm just giving you the name where like somebody like in maybe you have some viva in the final term. Like I'm not sure in India, like some of the teachers
Sir,
take and some
I
not.
have a doubt. Like I
Yes, yes.
mostly get confused between centrifugal and centripetal force. So
Okay,
can you
okay.
just clear it a bit?
Let me take one circle here.
Centrifugal and
And
centripetal.
centripetal. Very good. Okay, dear. Don't worry. Okay. So you have to like you are asking centripetal and centrifugal. Okay. Let me understand you the word centripetal here. Centripetal is a force which is
Which
inward force towards the radius.
yeah.
Towards radius. Now tell me, if the sun is revolving around, if the earth is revolving around the sun, is there is a force between sun and earth?
Yeah.
Yes or no? That's why it is
Yes, the
continuously
centripetal
revolving.
force.
Yes or no?
Yes, sir.
Yes, sir.
So that's an inward force. Suppose earth is this and sun is present here. So sun is attracting towards it. So that
Yeah.
force which is towards radius
Gravitation.
is called as centripetal.
Yes, sir.
Because it's a very deep topic, so that won't be very helpful for you in this class itself. So I'm just giving you the brief about it. Okay.
Yeah, so I
Centripetal
just
force.
remembered
Centripetal
centripetal and
force is the
centrifugal.
force towards radius. Clear?
Yes, sir.
And centrifugal is the force which is away from radius. Have you seen that dryer in your machine?
The bus, sir, bus as well.
Yes, bus as well. Have you seen the laundry dryer in your machine, in your washing machine?
Yes, sir.
You have seen that when you put the clothes into the laundry dryer, what will happen basically? How does that is there any magic like if you put the wet clothes and suddenly when you take out the clothes, it's completely dry almost?
No, sir.
They are at least like almost all the water is completely out from the clothes.
Yeah.
Yes or no? So that's what centrifugal force is.
Yes.
Centrifugal is away from radius.
Sir, which chapter is this?
Here you are late. Almost only 10 minutes class is left.
Sir,
This is
20.
motion.
Okay, sir.
This is last topic of motion chapter, uniform circular motion.
Sir, I had exams, so I couldn't attend classes.
Dear, that's not good, dear. Only you have one class of physics in the week and you are not able to attend it. That's not good. Please try to be more punctual.
Sir, from today onwards, exams are also allotted.
Okay. So away from radius. Okay. So don't worry, Aris. So recording will be there in your account. So don't worry. Just go through the recording before the next class.
Okay, sir.
Okay. Away from the radius. The force which is away from the radius is called centrifugal.
Fugal.
Alvina,
Yes.
Aris, and Spreshita. Is that clear to you, dear?
Yes, sir.
Any doubt in this?
No, sir.
Sure?
No doubt.
Sure?
Yes.
Like that's a very good thing that that's why that's a very good thing that Preshita had done. She asked some doubt. So basically it's a topic, it's a, you can say conceptual, knowledgeable part. So all of you can just do a little bit thing same like that Preshita had done in the class. So okay, before coming to the class, at least take something which is you can say related to real life. Clear, everybody? That would be more interesting to learn about the physics. Clear?
Yes, sir.
Okay, 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 Alvina. Yeah, yeah. I'm suggesting to like everyone, because each and every student is precious to me. I want that everyone succeeds. Clear? So that's why I'm suggesting. So have you got it? What is the force which is towards the radius? It's an inward.
Is called
Centripetal.
centripetal, and the outer force is
Outward.
called centrifugal.
Yes, very good. The hair, you can say the washing machine dryer works on the you can say principle of centrifugal force. Centrifugal force. Okay, because basically in India, in some of the rural areas, there is a process of basically, you can say ghee process, like removing out the ghee from the butter, or you can say cream from the butter. So they
the
use
buttermilk.
yes, they use the centrifugal force process. Clear? So that's, you can understand that we are applying the physics in a normal life,
sir.
and we don't even know that we are using physics in such a good manner.
Yes, sir.
Yes.
For example, when we are sitting in a bus and the bus
Yes.
takes a turn, so our
Turn.
body moves outside the
Yes,
like on
outside
the
the bus.
opposite side of the turn.
Your basically centripetal force pushes you towards the basically in which direction the bus is moving, but the centrifugal pushes in the outward motion. Bus is taking turn like this way, centripetal push you in this way, and centrifugal pull you in this way. Clear?
Yes.
Now, is everybody clear?
Yes, sir.
Any doubt, Alvina, Preshita?
Yes, sir.
Any doubt here?
No doubt, sir.
No doubt?
No.
Very good. Okay. So only one type of numerical can be there. I'm not sure. Like only conceptual part is there in your syllabus. I'm just telling you the formula. It's a simple formula. If you need to find out the value of the velocity, suppose that question has given that that this is the radius of the circular path, and you have to find out the velocity. You just need to do what? Can you tell me what is the distance of the one circle? What should be the distance? If you need to find out the speed of the uniform circular motion, can you tell me what should be the distance of one circle? What distance will it cover if you complete one round?
The circumference.
The circumference. What's the value of circumference?
2 pi r.
2 pi r. And distance divided by what is basically speed? Prishita, Alvina, Ariz, why? Everybody silent?
Time, sir.
Time. Very good.
Yes, sir.
Clear, Alvina and Ariz?
Yes, sir.
Any doubt in this?
No, sir.
So that's how you will find out the value of the circular motion. If somebody if there is a question, I have I can take one question so that you can apply this formula on the same. Let's do this thing. Just a second. Let me take another again the snapshot because of little bit crop it. So R is what? Can anybody tell me what is R?
Sir,
Radius.
Okay.
R is radius, sir.
Yes,
Radius.
radius of circular path. Radius of circular path. So you have to say that circular path as well, because radius is what? So we are dealing with the circular path, uniform circular motion. Clear, everybody?
yes, sir.
Yes, sir.
So next time R is be on time, dear. Okay, because
Okay,
the
sir. After
class is of only
from
1
now
hour.
on,
The class is of only 1 hour. If you miss any of the 15 minutes of class, so like 45, only 45 minutes time will be left for you. So that is like a little bit, you can say, not efficient class for you, dear. So that's why I'm requesting, please be on time, everybody. A cyclist goes around a circular track once every 2 minutes. If the radius of the circular track is 105, calculate its speed. So what is given here? What is given here? R is given 105 meter. Time is given in minutes.
Yes.
What I need to do is that 2 minutes. I need to convert it into seconds.
Yeah.
Not 120. It would be 60. 120 second. Yes or no? Everybody.
yes, sir.
We need to find out the value of V. Okay. The formula is V is equals to 2 pi R by T. Yes or no?
Yes, sir.
Yes, sir.
Pi value
Yeah.
is 22/7 into R is 105. Time is 120. So this is a
120.
double division. So can I take this in denominator?
Yeah. Yes.
Is everybody clear with this step?
Yes, sir.
Okay, very good.
Sir, wouldn't it become 2 into 22 into 10 into 120 divided by 7?
No. It would be in denominator. If there is something x, suppose x, this will go in your numerator. Whenever there is a double division, the
Okay.
denominator part division, that numerator will go in the denominator and the denominator will go in the numerator. So don't
Okay.
get confused in
Okay,
it.
sir.
Okay, dear?
Yes, sir.
Okay. So 2 into 22/7 into 10 into 120 into not 10, 105, sorry. R is 105 now. So now you can see that 7 is cancelling 105 term 35 times. Not sorry, 15 times, not 35, 15 times. 115 into 7 is what, dear? 7 5 31, 7 1 is 7 and 3 10, 105. Is everybody clear with this?
Yes, sir.
Okay. So V will be equals to what? 2 into 22 into 15 divided by 120. So this is a multiple of 260. 60. 2 will cancel this. Again, 2 is 30 and 11 will be left. So 5 is also there, 15 is also there. 15 is a multiple of, you can directly take to 30. Is that clear, everybody?
Yes,
Alina,
sir.
Preshita, Aris,
Yes, sir.
please be honest with me. I want honest answer. If any of the step is not bothering you, tell me.
Yes,
Clear?
sir. It's clear.
Okay. So only thing left is 11. Yes or no?
Yes, sir.
11 by 2, which is 5.5. Tell me the units. Tell me the units, please. Why is everybody silent? Tell me the units. What will be the unit of this value? Is it unit less, unit or any? Tell me the unit at least.
Sir, meters per second.
Meters per second. Very good, Alvina. Very good. Meters per second. So this is your answer. That's how you will calculate the value of the velocity in uniform circular motion. Isn't it easy?
Yes, sir.
So
Yes.
that,
Sir.
yes, that's why I've taken like in exam, one question can be there of 2 marks. So is it like this is a similar thing which we have done in the previous topics. This is not a different thing. Only the distance will become 2 pi r. If the question says 2 rounds, your 2 pi r will multiply it with 2 rounds, 2 into 2 pi r. Why? Because 2 rounds, 2 circumference time, 2 times circumference will be covered. Yes or no?
Yes, sir.
Yes,
Any
sir.
doubt?
No, sir.
No, sir.
No.
So now we are officially done with the motion chapter. Okay. I will after this class, I will send you some of questions mixed with like all the concepts will be there, like uniform circular motion, uniform motion, accelerated motion, equations of motion, and inertia. Was not inertia, like normal questions on the basis of graph. So that would be a kind of assignment worksheet. Like I think 7 to 8 questions will be there of like each and every concept covered will be from motion chapter. Clear?
Yes, sir.
Any doubt in this?
Yes, sir.
Yes.
No doubt,
No.
sir.
So are you done with this? Like any doubt, please let me know, be honest.
No, sir.
Okay. So Aris, you can do one thing. After this class, the video will be uploaded on your account as well. Okay. So go through that recording. That's a very short topic. Nothing much more than that. Okay. Don't worry about it. Okay.
Okay, sir. Sir, motion chapter already came in exam, so now I need to study.
Yes, Abdul. Oh, sorry, not sorry, Aris.
Sir, I already studied motion for exam. I need to study only gravitation for this exam. Next exam.
Okay. So we will discuss that thing as well. We will discuss that thing as well. So I have to end this class right now, dear. So let's end this class.